The problem where we left off, right, says to find the limit, okay? And it's the limit as x approaches 0 of this problem. When you plug 0 in here, you get 1 over 2 here. You get 1 over 2 in the first one, right, because x is 0, minus 1 over 2, that's 0. Over 0, you get 0 over 0, which, again, indeterminate, it doesn't get anywhere, okay? All right, so we need to simplify this somehow. In the first problem, A, we said one way to do that was to factor. In the one, number 29 that you did for homework, we said another way was, to multiply it out, simplify, and so on, right? Okay, how about if you have something like this? What you're going to do is the following. Take a look at, so here we're going to do limit x approaches 0, right? Okay, so here's what you're going to do. Look at the top, right? Do you see how the common denominator for the top is 2 plus x times 2? Yeah. Right? So you're going to multiply this whole thing by 2 plus x, but also the bottom 2 plus x. Okay? Because that's the common denominator of the top part. Okay. Now, so here we draw this. Okay? Distribute. So the first fraction times this, it's going to be the 2 plus x's will go away, so I have 1 times 2. That's 2. Okay? Minus the second fraction times this, the 2's go away, so you just have 2 plus x. So when did you minus? Hang on, please. Okay? On the bottom, you have x times 2 plus x. Okay, hang on. Now, this is equal to limit x approaches 0. When you distribute the negative on top here, you have 2 minus x. That's just negative x, because 2 minus 2 goes away. Over 2x, 2 plus x. Okay? Now, when I plug 0 in now, I still get 0 on top and 0 on the bottom, so I still haven't done anything. So, cancel out the x, cancel out the x. This is the limit as x approaches 0. What do I have left in the numerator? Negative 1 over 2 plus x. Now you can plug it in. Okay, now plug in the 0, and you get negative 1 over 2 plus 0, negative 1 over 4, and that's the answer. So again, before we got 0 over 0, that was indeterminate, because, you can't work with that. But then you simplify it, okay? Milan. So, all right. So let's talk about one-sided and two-sided limits. Sometimes all we need is to look at a limit only from one side. Remember how yesterday we said you have to look from the left, from the right? Sometimes all you need is the left side only or the right side only. When does that happen? We'll get to it. But what does it mean to have a right-hand limit? This is when you find the limit from the graph, right, of f of x as x approaches c plus. Do you see that? C plus means as x approaches c from the positive side. So where is the positive side, left or right? Right. So as x approaches, the number from the right-hand side. And then the left-handed limit is the limit of f of x as x approaches c minus from the left-hand side. So it's going positive. yeah, it just goes over from the left side and then over from the right side. So if, like we said yesterday, this is just a repetition, if the limit from the positive side and the limit from the negative side both equal the same number, then we say the limit exists. Okay? So let's talk about. That's where it's from. Yes. Okay. So it's okay. So take a look.
Sorry.
Okay. Okay, later, please. Okay. Okay. The limit of f of x as x approaches 0 from the negative side, right? Take a look. As x approaches 0 from the negative side. So where is 0? Right here. This is x is 0. As x approaches 0 from the negative side, that's here.
Yeah.
Right?
Yeah.
So this is 0. This is x equals 0. Okay, hang on. The limit as x approaches 0 from the negative side means what value is the graph taking on to the left of 0? To the left of 0, where is the graph here? Now, when I say to the left, I don't mean there, right? We talked about this yesterday. I mean, it's like infinitesimally close, like 0.00001 over, right? So immediately to the left of x equals 0, the graph is here at y equals 5. So I say the limit as x approaches 0 from the negative side is 5. Now, the limit as x approaches 0 from the positive side, so here is 0. From the positive side, immediately to the right of 0, where is the graph? Up here at around y equals 5. Now, because from the left and from the right of 0, the limit is 5, we say the limit as x approaches 0 is also 5. Okay? Because the left and the right limits are the same. Now, let's go to -3.
What is the left and right limit?
Huh? Okay, hang on. Let's do the next one. So as x approaches -3 from the negative side, right? From the negative side, what's the limit? What's the limit from the negative side? 0. Okay.
The immediate left, there's nothing there.
Okay, look. Where's -3? Right here. This is x equals -3.
Too far away.
Immediately to the left. Okay, where's the graph? Not here. That's just exactly at 3. Immediately to the left, the graph is here at 0. Okay, y equals 0. And then as x approaches -3 from the positive side, so immediately to the right, what y value does the graph have? 5. Okay, because these are not the same, we say the limit at x equals -3 is dne, which means it does not exist. You cannot write undefined. You cannot write no solution. You say dne. And please, they're just capital dne, okay? Yeah. No, because you're, hey, okay, the closed circle is at x equals -3, correct? Okay, but we're not looking at x equals -3. This is the line x equals -3. Hang on, let me do that better. Okay, this is the line x equals -3, okay? When you see those points, we have to make them big enough here for your eyes to physically see them, but technically they're like the tail, like the head of a pin, right? It's like a pinhead. That's how tiny it is, okay? So when I say x is -3 from the negative side, all right, to the left of this line, where is the graph? It's here. Not here, but here.
Yeah, but from the right.
But from the right, where is it? Not at 2. That is only at that point 3, not to the right of it. In actuality, that doesn't look like this. That looks like this. Okay, so take a look at this one. We're gonna graph x minus 1 over x minus 3. So let's go ahead and take out your calculators, please.
Am I still in the degree mode?
It shouldn't matter for this.
How do I stop a split screen?
Control T. No, not right now. Hang on. Let me do this. I'll walk around in a second, okay? Okay. So listen up. So you graph this. This is how it looks. Okay?
Which do you graph?
X minus 1 over x minus 3. Just do Control T. It gets rid of the table for you. So this, we know from previous years that when you set the denominator equal to 0, x equals 3 is what you get. And at x equals 3, you see that there is a vertical asymptote. So right here, there is a vertical asymptote at x equals 3. Okay, now, the top here, you see that it's also approaching some sort of horizontal asymptote, right? And there's more than one way to find that. Let's do it by tracing. If you trace this and you go to the left, right? Look at the y values. It's increasing to 0.8, right? If you keep going. And if you keep going further and further, you'll see that it'll just level off at 1, right? Y equals 1. So here there is another horizontal asymptote, y equals 1. And the graph, you can see, looks like this. Okay, the horizontal asymptote isn't as important right now as the vertical asymptote. What we want to look at now is the limit as x approaches 3 of this function. So this is x equals 3 right here. That vertical asymptote is x approaches 3. To find any limit, you have to look at it from the left and from the right. So I say, okay, let's look at the limit of this function as x approaches 3 from the negative side. Okay, from the negative side. So so again, here is the vertical asymptote. Okay, here is negative 3. Immediately to the left of this, the graph, you see it's going all the way down to negative infinity. So I say the limit there is negative infinity. Okay, now we're going to do the limit as x approaches 3 from the positive side of this. So where is it going immediately to the right of the asymptote? Up to positive infinity. Okay, now, because from the left and from the right, they did not meet at the same place. They are not going to the same number. We say the limit as x approaches 3 of this is DNE or does not exist. Okay? Because these two are not the same, the limit as x approaches 3 does not exist. Now, hang on. Okay, notation. You can never say the limit as x approaches negative 3 is equal to something, right? Is equal to like negative infinity. This doesn't work. You always need a function or something inside of there, okay? All right, very quickly, then I need to move on.
So if they're asking us how to solve that, we would have to show that it's different for both sides.
Correct. Yes. Okay.
And do we have to write a positive instead of infinity, or can I just write infinity?
You can just write infinity. Okay. So look at these. The limit as t approaches -4 from the negative side. So again, here is -4. Okay? So let's look at it from the negative side. To the left of -4, here is where the graph is, correct? Look at it another way. As you approach -4, what y value is your graph approaching? 1, 2, 3, 4, 5. What y value? 5.
So you're looking for the y value.
Yes. The limit as x approaches -4 from the positive side. On the positive side, here's the graph right here. What y value is it approaching as you get close to x equals -4? 2. Because these two are not the same, it's d and e. Okay, now, what's g of -4? 2. Okay, for that, you actually look at the point itself, so it's 2. Okay, next one. The limit as x approaches -2 from the minus side. How much is it? 3. From the positive side? 3. So the limit as s approaches -2? 3. And p of -2? 3. Okay? They can all be the same. They can all be different. It doesn't matter. One cannot exist. Okay. Next one. The limit as x approaches 2 from the negative side. 1. From the positive side. 1. What's the limit? And then what's g of 2? It's 3. It already says it there. But g of 2 is this one. Okay?
Why 1?
So look. Look, hang on. Look up here.
Oh, I didn't see that point. Obviously.
This point is 1, but the limit is,
I didn't see that little point.
okay.
You didn't see that point.
I didn't see that
Okay. How is which one 1? Okay.
How are they one? Is directly on the